Immediately following the seed and fertilizer drop, the closing discs engage. These angled discs are designed to meticulously throw soil over the newly placed seed, covering it to the optimal depth. This initial covering is critical for protecting the seed from desiccation, predation, and temperature fluctuations, while also promoting uniform moisture contact necessary for germination. Behind the closing discs on 2 of our planters are specialized shanks. These shanks serve to further cultivate the soil, gently pulling up additional earth to help build or sculpt the planting row. This process creates a slightly raised bed, which offers several advantages. It aids in drainage, warms the soil earlier in the season, and provides ample loose soil for subsequent hilling operations as the potato plants grow. To ensure absolute uniformity in planting depth and row profile, a drag bar is utilized. This implement trails behind the shanks, leveling off any excess soil that might result in overly tall or uneven rows. The importance of this drag bar cannot be overstated. Consistent depth is paramount for uniform emergence, which in turn leads to even plat growth, synchronized maturation, and ultimately a more efficient and higher quality harvest. Without such a mechanism, inconsistencies in depth could lead to varying emergence times, creating a heterogeneous field that is challenging to manage and harvest efficiently, impacting tuber size and quality. The actual loading of the planters from the field-deployed trucks is a systematic procedure. A dedicated loader, distinct from the cellar scooper, fills its bucket with seed potatoes from the truck. The loader then backs up, carefully positioning itself to discharge its contents into the planter's seed hopper. This process requires a precise and controlled approach, with the operator ensuring a slow and steady delivery to prevent any seed from spilling onto the ground, minimizing waste. Each planter requires approximately half of a full truckload of seed, meaning that to fully replenish all 3 planters, 1.5 trucks are typically needed. The sight of Christopher's planter arriving for its refill signals the continuous nature of this operation. A minor, yet frequently commented upon, characteristic of our loader is a persistent squeaking sound. It is imperative to clarify that this is not indicative of neglected maintenance. The squeaking emanates from the internal brake mechanisms within the axles, a known acoustic feature of their design, rather than from any joints or pivots. All external joints and bucket mechanisms are diligently greased as part of our regular maintenance schedule, ensuring smooth articulation and preventing premature wear. The efficiency of this loading sequence, combined with the sophisticated fertilizer application and precision soil management, underpins the successful initiation of the potato crop. The nuanced design and operational characteristics of our planters are pivotal to achieving high-accuracy potato seeding. Christopher's planter, in particular, showcases several advancements, differentiating it from the other 2. Unlike the 3-point hitch-mounted planters, his is a full hitch-mounted unit. This distinction often implies a larger, heavier machine designed for greater capacity and stability, better suited for high-speed operation across vast fields. The hitch-mounted configuration transfers less weight to the tractor's rear axle compared to a 3-point setup, which can be advantageous for flotation and reducing soil compaction. A key improvement on this new planter is the repositioning of the seed bin further back, providing enhanced accessibility to the internal components, particularly the individual seed cups, which simplifies maintenance and adjustments. Furthermore, the fan system, crucial for the planter's vacuum/suction mechanism, has been redesigned. Instead of a small fan on one side and a larger one on the other, this new model features a double fan situated at the rear, driven directly from the tractor's PTO shaft. This integrated double fan system delivers a more consistent and powerful suction, critical for maintaining seed accuracy even at higher operating speeds. A significant technological leap in Christopher's planter is the integration of a dedicated GPS system for auto steering. This advanced feature allows the planter to autonomously guide itself through the field, adhering to pre-programmed planting lines with sub-inch accuracy. Real-time kinematic (RTK) GPS, often employed in such systems, relies on correctional signals from a base station or network, providing unparalleled precision. The benefits are manifold. Perfectly straight rows, which simplifies subsequent cultivation, irrigation, and harvesting. Reduced operator fatigue, allowing for longer, more consistent working hours.
minimized overlap or skips, optimizing seed and fertilizer usage, and ultimately, a more efficient use of land resources. This level of precision agriculture contributes significantly to operational efficiency and economic viability. Loading Christopher's planter presents unique challenges due to its design. Its large rear tires, while offering excellent flotation and reducing compaction, somewhat impede the loader's proximity to the planter's front section. This means the loader operator must exercise greater precision, often needing to maneuver the bucket over the top of the tires to adequately fill the forward sections of the seed bin. However, once the bin fills up, the seed can cascade more easily over the top, making the latter stages of loading simpler. Christopher's planter also features a convenient ladder, offering an elevated vantage point for observing the loading process and inspecting the seed distribution within the bin. The core of the planter's accuracy lies in its cup mechanism, powered by a sophisticated vacuum system. A yellow hose provides the necessary suction, drawing individual seed pieces onto silicone cups. Silicone is chosen for its non-abrasive properties, which protect the delicate seed pieces, and its flexibility, allowing for effective vacuum adhesion. As the cups rotate, carrying the seed, they reach a specific point where the white hose, the blow-off hose, activates. This hose delivers a burst of positive air pressure, gently releasing the seed piece, which then drops precisely onto the ground. This singulation process ensures that only one seed piece is dropped at a time, minimizing doubles and skips. The inherent flexibility and design of these silicone cups enable them to reliably hold the seed even as the tractor accelerates, ensuring consistent spacing. The planter is designed to maintain remarkable accuracy, often achieving up to 98% singulation at planting speeds of 5 to 6 miles per hour. This speed is significantly faster than what many conventional planters can achieve while maintaining acceptable accuracy, making this technology highly efficient for covering large acreages. While rough ground can impact accuracy due to machine vibration, in typical field conditions, the system's robustness ensures consistent performance. After the seed is placed, the closing discs meticulously cover it, followed by the drag bar. The combined action of these implements is crucial for establishing uniform planting depth and creating a consistent soil profile over the seed. The closing discs throw soil inward, enveloping the seed. Any excess soil that results in an elevated or uneven row profile is then leveled by the drag bar. This creates a consistently flat or gently mounting row, ensuring that all seed pieces are buried at the same depth. This uniformity is paramount for synchronized germination and emergence, which, from an agronomic standpoint, leads to a more homogeneous crop. A crop that emerges and grows uniformly is easier to manage in terms of irrigation, pest control, and nutrient application, and ultimately results in a more consistent tuber size and quality at harvest. Without the drag bar, variations in soil conditions or disc performance could lead to areas of shallow planting, vulnerable to desiccation or frost, and areas of excessively deep planting, delaying emergence and consuming more energy, causing significant variability in crop development.
During operation, we sometimes observe minor issues, such as leaky fertilizer valves, where small dribbles of liquid fertilizer are visible. While not ideal, these minor leaks typically do not significantly impact the overall application rate, though they highlight areas for routine maintenance. More critical, however, is the occasional mechanical failure, such as a broken closing disc. Josh, one of our operators, was observed repairing a disc on an older planter. These older models utilize a simpler 3-bolt attachment system, and the integrated bearing can fail, leading to the disc snapping off. This type of repair, though common in older equipment, underscores the importance of quick field diagnostics and on-site parts availability to minimize downtime. Today marks a critical juncture in our agricultural calendar, the commencement of potato planting. This intricate operation, foundational to our annual yield, necessitates meticulous planning and execution, beginning right from the seed cellar. The process is a testament to both modern agricultural efficiency and the enduring utility of robust, well-maintained machinery. Our day begins at the seed cellar, where a substantial portion of our seed potato inventory has been meticulously prepared.
These seed potatoes, harvested from the previous season's specific disease-resistant and high-yield varieties, have undergone a rigorous selection and cutting process. Cutting seed potatoes into smaller pieces, each bearing at least one eye or sprout, serves a dual purpose. It significantly increases the number of potential plants from a given volume of seed, thereby optimizing resource utilization, and it can stimulate earlier and more vigorous sprouting. However, this practice also introduces a critical biological vulnerability. Open cuts are susceptible to disease transmission if not handled with stringent sanitation protocols and appropriate pre-planting treatments. The economic implications of this initial stage are profound, directly influencing the eventual yield and quality, thus dictating profitability margins in a highly competitive market. Upon entering the cellar, we observe a truck already partially loaded, awaiting its full complement of seed. The heart of this initial loading phase is a seed scooper, a piece of equipment that, despite its venerable age of 60 years, continues to perform with remarkable reliability. Its longevity underscores a fundamental principle in agricultural investment. The initial acquisition of high-quality, durable machinery, such as those historically produced by reputable manufacturers like Sputnik, often translates into decades of dependable service, amortizing its cost effectively over an extended operational lifespan. This particular model, though older, is an integral part of our logistical chain, efficiently moving the prepared seed.
The scooper operates by driving directly into the pile of cut seed potatoes. As it advances, its mechanism gently yet effectively scoops the potatoes, channeling them onto a conveyor system. This system, an expandable miniature piler, then elevates the seed potatoes, directing them into the waiting truck. The piler itself, manufactured in 1974, mirrors the scooper's enduring functionality, demonstrating the engineering robustness characteristic of a bygone era. It's an interesting juxtaposition of aging mechanics performing a crucial high-volume task. The visual spectacle of the potatoes cascading down into the scooper and subsequently ascending the piler is a dynamic illustration of mechanical advantage. As the scooper penetrates the pile, the inherent instability of the stacked potatoes often results in a controlled avalanche effect, where large volumes of seed tumble downwards, replenishing the scooper's intake zone. This natural gravitational assist enhances the efficiency of the loading process, minimizing manual intervention. A minor interruption occurred with a slightly damaged vent pipe, a consequence of the continuous material flow and occasional shifting of the bulk pile. These vent pipes are critical for maintaining optimal storage conditions within the cellar, facilitating air circulation to prevent spoilage and inhibit the growth of pathogens. Their temporary displacement is quickly rectified, allowing the seamless continuation of operations. The plate situated at the bottom of the scooper's intake is a crucial design feature, engineered to prevent the overloading of the main conveyor belt. This mechanism ensures a consistent, manageable flow of seed, thereby safeguarding the belt system from undue stress and potential mechanical failure, which would incur costly downtime. The process is systematically repeated until the truck achieves its full capacity. Once loaded, it will proceed directly to the fields, where the next phase of planting will commence. Simultaneously, an empty truck will rotate in, ensuring a continuous supply chain from the cellar to the planters. This synchronized logistics operation is vital for maintaining the intensive planting schedule required for large-scale potato cultivation. The strategic importance of the potato as a global staple crop cannot be overstated. It ranks among the top 4 most consumed food crops worldwide, alongside rice, wheat, and maize. Its versatility in culinary applications, combined with its robust nutritional profile, makes it indispensable for food security in numerous regions. Globally, countries like China, India, Russia, and the United States are among the largest producers, with substantial commercial operations relying heavily on efficient planting logistics. Ensuring the quality and health of seed potatoes, therefore, is not merely a farm-level concern, but a matter with implications for regional and national food supply chains. Proper storage,
cutting and loading procedures are the first steps in a lengthy and complex journey from seed to market, impacting everything from harvest yields to consumer prices. The operational discipline observed here, even with decades-old machinery, exemplifies the foundational principles of effective agricultural management. With the seed potatoes efficiently transferred from the cellar, the logistical focus shifts to the expansive fields where the planting machinery awaits. This transition highlights the intricate coordination required to execute large-scale agricultural operations. The meticulous preparation of the fields and the precise setup of the planting equipment are paramount for ensuring optimal growth conditions and maximizing yield. A critical component of our field operations involves the precise application of fertilizer. Modern potato cultivation demands a highly calibrated nutrient delivery system, given the crop's significant nutritional requirements throughout its growth cycle, particularly for robust tuber development. Our tractors are equipped with substantial fertilizer tanks. One boasts a 1,000-gallon capacity, another 800 gallons, and a third 600 gallons. These primary tanks are complemented by additional 200-gallon tanks integrated directly onto the planters themselves. This multi-tiered liquid fertilizer system represents a strategic investment in efficiency. By consolidating such large volumes of fertilizer, we achieve a significant reduction in operational interruptions. The ability to fill the fertilizer tanks once at the start of the day and subsequently plant for an entire day without requiring refills dramatically enhances productivity. This contrasts sharply with previous seasons, where smaller tank capacities necessitated frequent refills, often every 2 planter loads of seed, leading to considerable downtime, increased labor hours, and higher fuel consumption due to additional transport movements. The presence of a dedicated fertilizer supply truck on standby further mitigates any potential for delays, ensuring continuity even if an individual planter's tank unexpectedly runs low. This proactive logistical planning is a cornerstone of modern, high-intensity farming. The mechanism for fertilizer application is equally sophisticated. The liquid fertilizer is drawn from the tanks and channeled through a John Blue pump. This particular pump is noteworthy for its ground-driven design, meaning its operation is directly linked to the rotation of the planter's tires. This mechanical connection ensures that the fertilizer application rate is precisely synchronized with the planter's ground speed, maintaining a consistent dosage per linear foot of row, irrespective of minor speed fluctuations. The John Blue pump functions as a squeeze pump, employing a peristaltic action to move the liquid. It is equipped with specialized check valves, which are crucial for preventing backflow or siphoning when the planter is stationary. These valves ensure that fertilizer only flows when actively pumped, preventing wastage, minimizing environmental contamination from unintended spills, and preserving the integrity of the fertilizer delivery system. The absence of a dedicated fertilizer supply truck on standby further mitigates any potential for delays, ensuring continuity even if an individual planter's tank unexpectedly runs low. This proactive logistical planning is a cornerstone of modern, high-intensity farming. The strategic placement of the fertilizer is fundamental to early plant vigor. 2 hoses deliver fertilizer to each row, discharging it precisely next to the dropping seed piece. This starter fertilizer application provides an immediate, localized nutrient boost as the seed germinates and begins to develop roots. This proximity to the nascent plant optimizes nutrient uptake, particularly for essential elements like phosphorus, which are less mobile in the soil. Adequate early nutrition is vital for establishing a strong root system and vigorous vegetative growth, setting the stage for higher yields. From an agronomic perspective, this method capitalizes on the principle of precision agriculture, delivering the right nutrient in the right place at the right time. The choice of liquid fertilizer also allows for a more homogeneous distribution and quicker absorption compared to some granular forms, especially in drier conditions. From the vantage point of the tractor cab, a comprehensive overview of the planting operation is possible. The repositioned bin on Christopher's new planter provides an unobstructed view of the rows, allowing the operator to monitor the process effectively. The pulsing of the squeeze pump, responsible for fertilizer delivery, is visibly active. Within the seed bin, a network of feeder chains continuously supplies seed to the cups. An electric eye sensor monitors the seed level, triggering the feeder chains to activate and replenish the bin when the seed quantity drops below a predetermined threshold. This automated system ensures a consistent supply of seed to the cups, preventing misses where cups might otherwise remain empty. However, maintaining the optimal seed level is a delicate balance. If the bin is too full, excess seed can be thrown out or impede the cup mechanism. If too empty, skips, cups without seed, will occur. While the system strives for near-perfect singulation, occasional skips, or doubles, 2 seed pieces on 1 cup, are inevitable. Skips lead to unutilized land and reduced yield, while doubles result in overcrowding, competition for resources, and often smaller, less uniform tubers. Despite these minor imperfections, which are inherent to almost any mechanical planting system, these planters consistently achieve 95 to 98% accuracy in seed placement at operational speeds of 5 miles per hour. This high level of accuracy, coupled with operational speed, is the primary reason for our preference for these planters, even considering their slightly higher maintenance requirements due to a greater number of moving parts, including the PTO, multiple bearings, and the sophisticated fan system. The trade-off between increased maintenance and superior performance and efficiency makes these planters a valuable asset in modern potato farming. Reaching the end of a field segment marks a crucial point in the planting process, necessitating a precise and efficient turnaround. With Christopher's hitch-mounted planter, the integrated GPS steering system significantly streamlines this maneuver. As the tractor initiates its turn, the planter's rear wheels automatically adjust their angle, preventing the large implement from swinging too wide or colliding with the tractor. This autonomous turning capability not only enhances maneuverability in tight headlands, but also maintains the integrity of the GPS-guided path, ensuring that the planter is perfectly aligned for the next pass. The system's ability to return to center after a manual steering correction further exemplifies its advanced automation, allowing the operator to focus on other critical parameters rather than constantly wrestling with steering. Such automation drastically reduces operator fatigue over long planting days, which can extend to 12-16 hours, contributing to consistent performance throughout the shift. The planter's operational intelligence is centralized in its sophisticated monitor system, which serves as the primary interface for the operator. Christopher, our experienced operator, provides a detailed overview of its functionalities. The monitor displays a wealth of real-time data crucial for optimal planting. A master on-off switch controls the seed wheels, while an automatic raise and lower function is preset to specific heights for the front and rear sections, ensuring consistent ground clearance during turns and transport. The display clearly indicates a 6-row planter, further detailing 2 feeder chains per row, right and left. A numerical input, 11, sets the desired fullness level for each bin where potatoes are discharged from the feeder chain, illustrating the system's granular control over seed supply. The monitor visually confirms the movement of these feeder wheels, depicting potatoes dropping off, providing an immediate visual cue of the system's operation. Critical performance metrics are continuously updated. The system displays the chain speed, ensuring that the dropping rate of seed potatoes is synchronized with the planter's ground speed, especially vital when operating at 5 miles per hour. Drop sensors provide real-time feedback on seed delivery, showing an average accuracy of 92%. A crucial safety and efficiency feature is an alarm that triggers if the accuracy drops below 70%. Alerting the operator to potential blockages or mechanical issues that could lead to skips and reduced yield. The target seed spacing is clearly displayed, for instance, 11.75 inches per seed piece, directly correlating to the desired planting density per acre. This metric is a cornerstone of precision agriculture, ensuring optimal plant population for nutrient and light competition. The monitor also shows the actual planting speed, the acreage covered per hour, e.g. 10.5 acres per hour, and the total feet planted since activation. Beyond real-time data, the system allows for depth adjustments on the front unit with the save function to store preferred settings. Advanced calibration options, totals for hours and acres, and trip counters, trip 1, trip 2, offer comprehensive operational logging. For example, Christopher's new machine has already logged 106 acres, contributing to a total of approximately 400 acres planted across all 3 machines, demonstrating the scale of the operation. A rear-mounted camera provides invaluable assistance, particularly when backing up or maneuvering in tight spaces, preventing accidental collisions and enhancing safety. Christopher expresses a strong preference for this new monitor system, highlighting its superior user interface and integrated control, which has replaced older, less intuitive Raven sprayer controls used in prior planters. This technological leap significantly improves operator efficiency and reduces the cognitive load associated with managing complex agricultural machinery. The sheer scale of this operation is impressive. With 3 planters in continuous operation, the team aims to plant approximately 200 acres per day. The total acreage for this planting cycle is 1,200 acres, projecting completion in a mere 6 days, assuming ideal conditions. However, as is common in agriculture, unforeseen challenges often arise. The oldest planter, a 2004 model, frequently experiences mechanical issues, notably broken closing discs. This constant maintenance requirement on older equipment highlights the ongoing capital expenditure cycle in farming, where the efficiency gains and reduced downtime of newer machinery often justify significant investment. Another planter, located at the far end of the field, is also currently experiencing issues with its closing discs, underscoring the susceptibility of these high wear components. A common question in irrigated agriculture pertains to planting around center pivot irrigation systems, which are essential for water-intensive crops like potatoes, ensuring consistent moisture for optimal tuber development. Our strategy involves 2 primary methods. One approach is to temporarily move the pivot out of its normal resting position, plant the area directly beneath where it typically sits, and then reposition the pivot. The alternative involves planting a section of the field, then moving the pivot over the newly planted area and continuing to plant the remaining sections. Both methods fundamentally involve temporarily displacing the pivot to access the underlying soil, ensuring complete coverage of the field while maintaining the critical irrigation infrastructure. This logistical challenge reflects the strategic decisions involved in optimizing land use and integrating diverse agricultural technologies. The sight of all 3 planters simultaneously filling up, followed by Christopher's immediate departure to resume planting, encapsulates the synchronized, high-intensity nature of modern potato cultivation, where every minute saved in logistical transitions contributes to the ambitious goal of completing 1,200 acres in under a week. The global potato market, valued in the tens of billions, relies on such efficient, large-scale operations to meet consumer demand for fresh potatoes, processed products like chips and fries, and industrial starch. The precision agriculture practices demonstrated here, from optimized fertilizer placement to GPS-guided planting and real-time monitoring, are not just about maximizing yield, but also about enhancing resource efficiency and fostering sustainable agricultural practices for this vital global crop.